So instead of putting my money into the stock market, I did something worse. I'm working on the trade maxer. That's the name I figured. I don't know what I'm doing. God damn it, why did I choose to do that? Burning through money in an automated way. Very stupid moves indeed. I tried to build my own trading chip. It's not a trading bot. It's not a program running on a server. It's not that. But it's an actual piece of hardware whose only job is to look at the markets. Every day, all day. It never stops. Of course, doing such a project is not going to be trivial, and there is a little bit of work to do. So first of all, how does trading works? So I want you to imagine you are a guy in the 80s trying to sell a stock. So at this point, what you would do is that you would pick up your phone and you call your broker or whatever. And so you would tell him, hey, I want to sell a stock, like an IBM stock. So the broker's job is extremely simple. He just has to find someone who's ready to buy it from you. Back then, to do that, you had these big rooms where everyone is shouting. The whole goal is for two people to agree on a price and there's a trade. So fast forward to today. Conceptually, the process has not changed. Instead of people shouting, the market is a continuous stream of orders. And you can see what's happening live on the market using live market data coming from exchanges like the Nasdaq. I'm yapping about this story, but how does this have anything to do with our trading chip? Well, orders and market events does not happen at slow speeds. It happens millions of times per second. Millions.
Vous voyez ce que ça fait déjà 1 million, Armina?
So if you want to react on what's happening on the market, you have to be very fast. You have to keep up with that stream, right? So why do you want a trading chip? People that are way smarter than me made actual trading strategies. But everyone does that nowadays, right? Like there are many quants in the market that tries to make the perfect strategy. When the strategy is based on speed, you want to be the first one to execute your strategy to get the bags. If you take like just a little bit too much time, someone else is going to take that opportunity instead of you. Like you are going to be too slow. And this speed can be measured in nanoseconds. And you are going to tell me, yes, but C++ is very fast, you don't need a trading chip, yada yada yada. Software engineers spend hours trying to do a very fast algorithm that executes in microseconds on a CPU, but you have to know something. Their CPUs, no matter how hard they try to make their C++ code as fast as possible, it's just never gonna beat dedicated hardware. So with that in mind, you may think that making dedicated hardware is hard and it takes time. You have to do this thing where you put engravings on silicon and stuff. Well, here's a plot twist for you. We don't need to make custom silicon chips to make custom hardware, because there is one thing that comes to the rescue, and it's FPGAs. You guys may know FPGAs if you follow my channel, but for the newcomers, an FPGA is a chip that embeds programmable hardware. It works with logic blocks that you can program, and then it just runs your custom hardware. I'm not going to get into the details because it's a little bit of a rabbit hole, but you get the idea. And for high-frequency trading systems, having a reliable FPGA and PCB carrier is crucial. And it may be the difference between being completely successful or being completely bankrupt. And when it comes to having a great PCB manufacturing process, PCBWay is just the way to go. They make it so easy to prototype both simple and complex designs for all of your needs. They also offer 3D printing services and CNC services. And I worked as a CNC operator before, and I can tell you that the possibilities with this are just endless. So as a maker looking to prototype some custom tools, or as a professional looking to get your FPGA PCBs out in the wild, PCBWay is definitely the great partner So a big thanks to PCBWay for sponsoring the work and this video, and we are getting back to building a custom trading chip. So with that in mind, all that's left to do is to create custom hardware with no processor, just raw hardware logic to parse and process market data. It sounds hard because it is. That's because it is. So the way we are going to create custom hardware is using HDL, which is a specific type of programming language that describes hardware. So you have multiple languages, you have Verilog, VHDL, Spinal HDL, whatever. There are tons of languages out there, but in the end, it's always the same thing. You describe hardware using code, which I know is very nerdy, but it is what it is. And so this code describes circuits that will then be implemented in the FPGA. Now, a very powerful tool that we can use when working like that is simulation. And this allows you to catch bugs early on without having to go on a real FPGA, which is very hard to debug. Because it's just simulation. That's the easy part, and it already took me 2 fucking days. So, now that we know how to proceed, we can start printing money, right? Okay, so the first step is going to get market data somehow. So lucky us, the Nasdaq actually broadcasts live market data to its subscribers. And from a device perspective, we can retrieve this data using Ethernet. The protocol they use is a custom protocol. It's called each 5.0 whatever, and looking at the specs, it's actually pretty simple. You don't really want overhead when there are millions of messages per second, so it makes sense that it's pretty simple. And lucky us, in the previous video, I designed an Ethernet MAC to receive Ethernet data. So we already have the receiving end of the design. So now, all that's left to do is to parse the each messages coming in. So I got to work making an each parser, which I have to say went pretty well. So I just finished message parsing and it's looking pretty good. I mean, look at that. And after a lot of very happy tinkering, we finally have an each parser that is able to listen to market data and interpret the market data, which is great and all, but in itself it does absolutely nothing. Like, it just interprets and forgets. We want some sort of way to keep tracks of what's going on. And this is where we start to get in deep. We also have some problems with the way you store the orders, because they can be 2 to the power of 64 different entries, which we obviously don't have in an FPGA. Because there are a lot of possible order references. Each order has its own ID or reference, and it's 64 bits wide, which is a little bit too much to store, especially on an FPGA. So with this constraint in mind, I came with a little design that looks like this. I then tested it to see if it works well. Of course, given the low amount of available memory, we do come across some collisions, but I'm okay with that. Of course, in a real system, it's like not gonna cut it. You do not want collisions, but personally, I don't really care. I mean, if it works, it works. And that is great. But I wanted a way to quickly find out how the market is looking. And there is a tool for that, and it's called the ladder. I mean, I don't know what it's called, but I call it the ladder, all right? Because it looks like a ladder. It allows you to quickly see how many people are trying to sell and how many people are trying to buy. It lets you see the spread of a said market, etc. And so to recreate that, I used the order book from before to generate state commit signals. These state commit signals will then be used by the ladder to update its state. Inside of the ladder, there is just a 4 kilobytes VRAM to store 4,000 in whatever different price entries. The price step is a power of 2. You may have noticed that it's not really great looking, but this is because in hardware, dividing by a power of 2 is basically free, but dividing by something else is extremely expensive. So that's just a little trick to make things a little bit easier to implement on an FPGA. And I also made the ladder a bus slave. We can use this VRAM as a bus slave in order to retrieve the actual market state. So making the ladder a bus slave makes it easy for a CPU like my Holy Core to go and retrieve the market state to actually visualize it. Okay, that's kind of weird. And after a lot of debugging, I finally have a working ladder. Okay guys, this is a moment of truth. The Apple stock market at a given time. These are the person trying to buy, and these are the persons trying to sell. And here in the middle is called the spread, and is where people kind of meet. Of course, all of this is just a simulation, and right now we are just keeping track of the market state. In a real system, you also want to implement a trading strategy that is able to figure out what's going on in the market and actually make trading decisions. But you know what? I can try it out. And I can already tell you that it's not going to be trivial, but this is going to be the subject for another video if you guys liked this subject. So do not hesitate to leave a like and subscribe to manifest your interest in a second video where I actually test out the design on an Fpga and maybe implement a little trading strategy. With that being said, I'll see you in the next one.